So this lesson is all about notation. The word notation refers to how we write or express our answers once we get an answer. So we're talking about set theory here, and there's a very specific grouping of symbols that we use. Our first set, we're going to say, is set A, and we'll keep it nice and simple. Set notation is going to have 1, 2, 3, and we'll go through 5. And so we're talking only about these sets of numbers. Now we want to introduce a new notation. It's called an element notation, where I can say that, for example, 4 is an element of, here's a new symbol, sort of a weird looking E thing, is an element of A, meaning 4 is in A. It's a part of A. Whereas I could say that four is an element of A. Here we go. Yeah, so that weird looking E symbol between the 4 and the A is an element of A. So anytime you see that from now on, it just means that the left side is inside of the right side. So I could say that, let's say the number 10 is not an element of A. So in that case, I would write the element symbol, but I would put a strike through it, like a no smoking symbol. Because if I look at the set A, 10 is not in there. So we're going to use that element of notation here in just a moment. So we're going to go ahead and start out with our first example. And we're going to use the same set A, and we're going to actually find a way to rewrite it using what's called set notation, or set builder notation. And so I'm going to find a way to rewrite A being 1, 2, 3, 4, 5 a little bit more mathematically. And I'm going to say that A is the set of all x's such that, that's what that vertical line means, such that x is less than or equal to 5, but it's not all numbers that are less than or equal to 5, it's specifically the natural numbers. So I'm going to say it's everything less than or equal to 5, and x is an element of the natural numbers. And there's a fancy symbol for natural numbers. You can ask your teacher what natural numbers are. Those are starting with 1 and then going on. But it's not 4.5 would not be included here. We're only talking natural numbers. Yeah, also called counting numbers, but it's the same thing. But we start with 1, 1, 2, 3, 4, 5. So, for example, pi would not be included here. 1.5 would not be included here. The natural numbers only refer to 1, 2, 3, 4, 5, starting with 1, 6, 7, 8, 9, 10, all the way up as far as we need to go. In this case, just up to 5. We're going to start with another set here. This one's a little different. This is set B, we'll say. And set B is going to be 12, 13, 14, and 15. And we're going to rewrite this one as well. In this case, we're going to say that B, again using our set builder notation, is the set of all x's as long as, or such that, x is between 12 and 15. And we're going to use our fancy notation here. Notice I'm including the endpoints, but I don't want all the numbers between 12 and 15. I want all the numbers including 12 and 15 and in between, as long as x is an element of the natural numbers, or the counting numbers. It's the same. So here's our new set builder notation. Lastly, we're going to talk about some other new notation. We're going to have a new set A. And set A we're going to have, we'll start with 0 in this case. 1, 2, 3, 4, 5. Set B in this case is going to be, we'll say some even numbers, 2, 4, 6, 8. And we're going to be looking first off for the intersection. Now, intersection symbol looks like this. It's sort of an upside down U. Intersection means and. It means everything that is inclusive of both sets. In this case, it's only going to be the 2 and the 4. So A, intersection B, is only going to be 2 and 4. Because intersection, or the AND case, means that we want both cases to be satisfied. 2 and 4 is in both sets. We're good. Next up, we have the union case, A union B. Here's the symbol for union. It looks kind of like a U. It's kind of easy to remember. Union means we want to include everybody, but we're not going to double count anything. So this will include 0, 1, 2, 3, 4, 5, 6, and 8. Not 7, because that's not in any of the cases. So please note the difference between intersection, which means and. So both cases have to, or both numbers have to be in both sets. Now the union case means or. These are numbers that are in one set or the other one, and we don't double count the overlap.